Welcome to the AI Research Roundup. I'm Alex. Today we're looking at RM-R1, Reward Modeling as Reasoning, from May 5th, 2025. This paper tackles how we teach AI to understand human preferences, a process called reward modeling, often part of reinforcement learning from human feedback, or RLHF. The big idea here is a new type of model, reasoning reward models, or REASRMS. Instead of just giving a score, these reasoning reward models first generate a chain of thought, a series of reasoning steps to explain their judgment, making them more understandable and often more accurate. Alright, and for those looking to get hands-on with these reasoning reward models, well, the code repository for this research is available. It's really set up to help you reproduce or build upon their results, offering things like end-to-end training scripts, configuration files, the data sets, and a unified evaluation harness, basically a standard toolkit to test how the models do. Okay, so figure 1 really highlights the core idea. It presents a scenario. Someone's feeling down about their job and gets 2 AI responses. One is supportive, the other sounds okay but is subtly harmful. Now, a typical instruct model, which is a model trained to follow instructions and pick an answer, it actually chooses the harmful one, probably focusing on surface details. But the reasoning reward model, using its chain of thought approach, first lists its evaluation criteria, its rubrics like empathy and non-harm, then explains why the supportive response is superior, getting at the deeper emotional impact. Okay, figure 2 now shows us the training pipeline for these RM-R1 models. At the top, it contrasts with simpler reward models. One just outputs a score, and another, called a generative reward model, or Gen-RM, just picks a better response. The RM-R1 training actually begins with such a generative reward model. It then goes through 2 main stages. First, there's distillation. This is where it's taught to produce good reasoning by studying high-quality examples, evolving it into an initial reasoning reward model. Then, this reasoning reward model undergoes reinforcement learning, essentially practicing making judgments and getting feedback to further sharpen its ability to evaluate responses accurately. Alright, so Table 1 lays out the results from Reward Bench, which is a benchmark, basically a standardized test, to see how well these different reward models perform across tasks like chat, reasoning, and safety. We see comparisons between scalar reward models. Those are models that just output a numerical score, and generative reward models, or Gen-RMs, which might pick a response or give a brief justification. And then, of course, our reasoning reward models. The key takeaway here is that the RM-R1 Coin-Instruct 32B model achieves state-of-the-art overall performance on Reward Bench, scoring 92.9%. It's also very strong in reasoning and achieves the top score for safety, which really shows how effective that 2-stage training process is. Moving on to Table 2, this gives us a more detailed look at performance on another benchmark, RM-Bench. This particular benchmark tests the models across different domains like chat, math, code, and safety, and also at various difficulty levels. The really striking result here is from the RM-R1 DeepSeek Distilled Quinn 32B model, one of our reasoning reward models. It actually sets a new state-of-the-art on RM-Bench, especially shining in reasoning tasks, with a fantastic 91.8% in math and 74.1% in code. This really underscores how well these reasoning-focused models handle complex evaluations. Okay, so Table 3 presents yet another leaderboard, this time for a benchmark called RMB. This one ranks models based on their average scores in helpfulness, harmlessness, and an overall performance metric. And again, we see our reasoning reward models performing very well. Specifically, the RM-R1 Coin-Instruct 32B model achieves near state-of-the-art performance with an overall score of 73.0%. It's just slightly behind a much larger proprietary model, which really highlights how effective these RM-R1 models are, even with more efficient training. This consistent high performance across different benchmarks is quite impressive. Okay, Figure 5 illustrates scaling effects for RM-R1, essentially how performance improves with more resources. The left plot, model size scaling, shows that as the model size, its number of internal parameters, goes from 7 billion to 32 billion, the performance improvement climbs from about 4% to over 6%. The right plot, inference compute scaling, deals with inference compute. Think of this as the thinking time or reasoning chain length, measured in tokens. Here, increasing the compute budget from 512 to 8,000 tokens lifts overall performance from roughly 76% to nearly 80%. So, both larger models and more extensive reasoning significantly boost these RM-R1 models. Alright, so after seeing how scaling up the model and compute improves performance, Table 4 here dives into an ablation study, which is a way to test which parts of a complex system are most critical by trying different combinations. This particular study uses the QHIN 2.5 Instruct 32B model on reward bench. We see the original instruction-tuned model, then one with just cold start reinforcement learning. That's reinforcement learning applied without the initial stage, where the model learns reasoning from high-quality examples. Then they add query categorization, or QC, which helps the model decide how to approach a task. The key finding is that the full method, which includes that initial reasoning distillation, then reinforcement learning, plus query categorization, yields the best overall score of 92.9%. This really shows how important each step in their proposed training pipeline is for achieving these strong results, especially that initial distillation of reasoning. That ablation study really underscores how each component, especially that initial reasoning distillation, contributes to the impressive performance of RM-R1. It's clear that by framing reward modeling as an explicit reasoning process, the researchers have developed a very effective method. This work is significant because it offers a new path to creating more discerning reward models, which are crucial for guiding large language models to be more helpful and aligned with what we want. That's all for this AI Research Roundup. Thanks for tuning in. I'm Alex.